Now, what I did that last time, you might have heard it, was I was mashing the key. And at that point, the browser was getting a lot of sounds overlapping each other and deciding on its own what to do because I wasn't telling it what to do. Let's make the sound softer. Divide by 8 so they have much softer volume. Let's overlap some of those. Still sounds like it's getting louder and softer because these sine waves are in many cases canceling each other out. If you have a sine wave and you just shift it over by 180 degrees or by pi, you have the minus that sine wave. So you add two random sine waves that you start at different times together, you're not necessarily going to get louder. I want an example where it will consistently get louder. I'm thinking of how to make one of those. Okay, here we go. Our phase equals this number. Actually, we don't need the pi in this case. Mod 1. So this number will go between 0 and 1 every 440th of a second. Mod 1 takes a number that's potentially greater than 1, just takes the fractional part. What it does to negative numbers is different, but we're never going to be negative here. So this is going to give us a number that varies between 0 and 1 over the course of the sound. Now, sound I equals so our sound is going to be either -1 or 1, depending on the phase. But instead of being an evenly spaced wave, we're going to be -1 for the first eighth of every wave and +1 for the remainder of it. I think Audacity will let me give an example of that. I was wrong. Audacity will not let me give an example of that. Oh, I know what to do. I know what to do. A nice little trick you can do on Audacity is record your own speaker output. So I will just set up to do that. So if this does sound good, then I can show you in Audacity. Reload. All right, let's just see what that looks like in Audacity. Yeah, as you see, we have the low, the high. Now these wavinesses are because ultimately on the way from the browser to the sound card, other mixing and resampling happens. You're never going to get exactly a square wave once you've done any sort of resampling. But you see it is low a little bit and high for the rest of the time. Now I'm going to make this volume a lot softer. Let's make it 1/10. So here I can stack them and they get louder as I play more of them together for the most part. But there's a limit. There's a point where the browser's like, no, you're loud enough. I'm going to do a thing where I just kind of cap your volume. And that's good. You do want it to cap the volume. The problem is it decides how. And something I learned on a past project. Firefox and Chrome have very different opinions about what to do when the total audios playing have a number that's greater than 1 or less than -1. I like Firefox's behavior better, but I learned a trick that can satisfy both parties. So what we need here is a wave shaper node, it's called. All right. So on load, I make the context. Now wave shaper dot curve equals new float32 array made from a regular array with the elements -1, 1. Okay, wave shaper has one input, one output. Or actually, I guess it has arbitrary inputs, outputs you can use with stereo just as easily. But it has same input as output. And it takes its input, takes that as an index into a curve, and outputs the value on that curve. So it can turn a linear wave into a sine wave, for instance, if I populated this with the values that a sine wave would have. But if I just populate with linear values, it does one neat little thing, which is consistent across browsers and well-defined. It will clamp whatever it's getting to this -1, 1 range. So if I pass this in numbers that are bigger than -1, that are bigger in magnitude than -1 and 1, if I pass it like a bunch of sounds that add together to more than 1, this wave shaper will output nothing bigger than the -1 or the 1. So let's connect the wave shaper to actx.destination. And then let's connect the source to the wave shaper when we play a new source. So the wave shaper sees the total of all these different things and decides what to do with them. Now in Firefox, this won't even sound different. In Chrome, however, we could get a pretty big difference, and I think I can demonstrate that for you. So we have one wave shaper node. This also has another nice effect. We could use it to get master volume effects if you wanted to. Let's actually do that, just so it's not going to waste. Wave shaper dot curve equals new float. So I'm just showing another use for having a wave shaper curve there. You could use a gain node instead of that, which gain node just needs one number for the gain instead of a 2-number range. But a gain node doesn't give you the nice clamping behavior that I'm actually doing this for. So now X and C should change my volume level. Yeah, I was pressing X and C at various points so you could hear it getting louder and softer. So we have this chain where we have our source nodes that are getting created here, and we have more than one of them. Those all go into the wave shaper, which has parameters that we can change. The wave shaper is then outputting to our audio context destination, and the audio context destination goes ultimately to the speakers after a little resampling, which is why, for instance, we had those spikies. So if we want a sound to play when a game event happens, that's very straightforward now. Let's just have this noise play when one game event happens, just to show you that. This video is getting to the point where I want to be cutting soon, so I'm not going to actually design the sound effects yet. I'm just going to demonstrate a thing happening. So if I go over to... How about when the player jumps and when the player double jumps? Let's do that. All right, so let's make 2 different example noises. This is wasteful. I should be using a common function instead of copying and pasting, but whatever. Let's have that be the different phase. All right, now, whenever I'm jumping. Right, jumping is where? Right, okay, this is the regular jump. Play example noise. And if I'm double jumping, let's play example noise 2. And if all's well, we now have a sound effect in the game, which we computed using a very simple wave equation instead of loading it from a file. Well, these sounds are so loud as to be actually really annoying. So I'm going to change that. I'm going to say instead of for 48,000 samples, let's make it 16,000. And the other 48,000 all refer to the samples per second, which is the same. So this should be played for 1/3 of a second now. That's still way too long because I'm jumping and my double jump noise overlaps my regular jump noise. Yeah, let's make this one higher pitched. Not the greatest sound effects in the world. This is probably consistent with Atari 2600 behavior, more or less. Definitely within Commodore 64's behavior possibilities. But the point is they're playing in response to a game event. And for less than a half hour programming, showing you that, I think, is pretty decent. I hope it has been informative for you. I might not record myself actually designing the sounds. I might just come back and talk about the formulas that I use for the waves after I've picked them. But I will be continuing this video series. And once I have sounds, I think that just leaves graphics pretty much. I think, yeah. So I will see you soon. Bye.